Oh, I spell now.
Okay, so I will be recording today's lesson so I can use it against you on the college app. You know, I can send this in and this is how you behave, so. Anyway, I am videoing all of your lessons and so that they will be on Haiku if you are ever caught in traffic and can't get to school. So go to Haiku and you'll find, I have to chop them into little pieces, so there might be 5 of them. There might be 5 of them to make a lesson, but just follow, I'll put, like, this is 5.1. So I'll have 5.1.1 is the first one, and 5.1.2 would be the second video of today's lesson. So I'll have to chop it into little pieces. I did one whole lesson yesterday and it took 7 hours to upload. So I'm going to chop them up into smaller bits. So, chapter 5, we did 1 through 4, first semester. Computers down, please. Colin. Thanks. Radicals to start with. Square root of 16. If you don't see any sign in front, is there any plus or minus or plus or minus? No. If you just see the square root symbol, it wants the positive square root, not plus and minus. If they want the minus in front, they'll put the minus there already. So minus the square root of 16 is negative 4. If they want the plus and minus, they will put it there already. So plus and minus 4. What is the difference between these two? If the minus is in front, the square root of 16 itself is fine. Square root of 16 is 4. But what happens with the square root of a negative number? It's imaginary. So the square root of 4 is okay, the square root of 4 is 2. But it's 2i for the imaginary part. And we're in pre-calc now, so you should understand why the square root of a negative is imaginary. The cube root of a negative, however, is not imaginary. Because aren't you asking what can multiply itself 3 times and be negative 8? What's a negative times a negative times a negative?
Negative.
A negative times negative is positive, times negative is negative. So the cube root of a negative can be real. It's the square root of a negative, that's the problem. So don't start putting imaginary on cube roots. Cube roots of a negative work perfectly. Also, you can rewrite square roots as power 1/2, and everybody in the world will understand that a power of 1/2 means a square root. And a cube root is power 1/3. Nth root is power 1/n, 1 over n. Even your calculator knows this. If you take your calculator, what am I saying here? The square root of 25. What power do you write for a square root? What power do I write for a square root? Square root is power 1/2. If you just see that problem, you should say, that's a square root of 25 problem. What's the square root of 25? 5. And if you do that with your calculator, of course your calculator understands that. So if you do 25 to the power of 1/2, it knows the 1/2 power is a square root, and it will give you 5. So part of the assessments will be no calculator. What's the square root of 64? This is not a trick question. It's not 64 to the half power. It's just what is the square root of 64?
8.
8. What's the fifth root of 32?
Oh.
It must be something that you can do in your head. One thing you can do with these is turn them into a product of primes. Remember turning things into a product of primes? What goes into 32? What's the smallest prime number divides 32? 2 does. 2 goes in there. 16. What divides 16?
4.
Has to be a prime number, a little prime number. So the next smallest number that can divide 16 is 2, prime number. Goes in 8. What little prime number can divide 8? 4 times. And then, so what is 32? 2 to the 5th power. So what does that mean about the fifth root of 32? It's 2. Doesn't 2 times 2 times 2 times 2 5 times equal 32? That's what we just proved. So without a calculator, it must be something like that that you can work out. It may not be simple, but you guys are math quizzes, so. Any question about this? I see you're copying stuff, so. Cube root of -8 without a calculator. Is it imaginary?
No.
No, cube root of a negative is not imaginary.
It is
What can multiply itself 3 times and be 8?
-2.
-2. No calculator. What can multiply itself and be 0.04?
0.02.
Point two.
When you are multiplying decimals,
They get smaller.
like if I just gave you this out of the blue, it would be 6. 2 times 3 is 6. How many decimal places? How many decimal places does this have? And this one has, so all together they will have, the answer needs 3. So there you go. That's what it would look like, 3 decimal places. So it's 2 times 3 is 6 with 3 decimal places. What are we looking for? Something that can multiply itself and make 2 decimal places.
One decimal.
What if I do this? Times itself.
No, it would be.
How about this times itself? How many decimal places will that have? 4. We don't need 4 decimal places, do we?
Oh, 0.2.
Yeah, we need
Yay.
0.2 there. Because 0.2, how many decimal places do these have? 1, 2. 2 decimal places. So this will be 2 times 2 is 4 with 2 decimal places. There you go, 2 decimal places. Okay, with that idea? What about this?
0.003. I mean 0.0.
How many decimal places?
4.
4, so the square root needs 2. 2?
3.
Oh.
Sorry.
That's okay. Okay, so 0.03, 3 times 3 makes 9. How many decimal places does that have? 2, but another times the same one will have 2 more, makes 4. That's 4 decimal places. Okay? cube root. How many little guys are we going to multiply times itself this time?
3.
3. And how many decimal places do we need?
3.
3. So the original needs
1.
1, 2.
1.
If you're not sure,
1.
just try something. What is the cube root of 27 anyway?
0. 3 times 3.
Prairie and Javi, okay? 3 times 3 is 9 times 3 is 27?
Yeah.
So let's just try something.
3.
2 decimal places.
6.
But what are we doing? Cubing it, right? How many decimal places does that make? 2, 4, 6. Does this have 6 decimal places? Oops.
It's 0.3.
Yeah.
This is low.
So let's try 0.3. If I do 0.3 times 0.3 times 0.3, how many decimal places will that have?
3.
3. 1, 2, 3. Perfect. Uh, 0.2 to the 8th power. The square root of that. This is when powers become powerful. When powers become useful. What power did we say we could use a square root for? Square roots turn into what kind of power? Square root is power.
Oh, 1 is it?
Right. Wasn't a square root power a half? What do you do when you're multiplying powers here? When you have a power to a power? If you have a power to a power, you multiply. What's half times 8?
4.
0.2 to the 4th. What is 0.2 to the 4th power?
0.
What is 2 to the 4th power anyway? You're not done with this problem, sorry. 2 times 2,
32.
4, you
36.
went too far.
36.
No, 2 to the 4th power.
16.
5.
16.
3 to the 4. Oh, yeah.
2 times 2 is 4. 4 times 2 more is 8.
Oh.
8 times 2 more is 16. No calculator allowed, so. But how do you write 16 with, how many decimal places does this need? If it's this times this times this 4 times.
4.
4 decimal places. So how do I get 16?
0, 0,
0, 0,
1, 6.
1, 6. Is that 4 decimal places now? Okay, so we're finally done here. So, if you see this, be sure and remember to turn it into a half power so you can at least reduce this a little bit. The alternative is to take 0.2 times 0.2 times 0.2 8 times and then try to think what the square root of that would be. That's much harder than this. This might have been tricky, but if you didn't do the little reducing down, it would have been quite harder. So do this one.